So today's class we will be learning very interesting concept, very interesting. It comes in the category of networking devices only. Okay, it comes in the topic of networking devices only, and the device name is router. Device name is router. Everyone has in their homes. Not everyone. Okay, the person who wants the Wi-Fi access, internet access, unlimited internet access, have these in their homes. And if they don't have this, to get an internet connection, ISP is using large amount of routers. What router actually is? We will start. Okay. First of all, a router is a device. Which is used to send data packets across the networks. Okay, which is used to transmit or send. Okay, send or receive. It is better to say transmit. Send or receive data packets across the networks. Here it is very important. It's not network, it's networks. Within the network, we have switch. We don't need router. Okay. Outside the network, once we go outside the network, we need router. Why? I'll explain you. Okay. What is a packet? First of all, what is a packet? Okay. Packet. What is packet? Data at the network layer of the OSI model. Network layer of OSI model is called as packet. Now, this contains user data, okay, plus it contains source IP, plus it contains destination IP. Okay, packet contains these three information. Okay, these three informations. It contains the user data, it contains the source IP, it contains the destination IP. Okay, fine. Okay, so packet is nothing but the data at a network layer. Once the data tries to go outside the LAN, outside the local LAN network, mainly packet is used for identifying where to send the data and where it is coming from. Okay, mainly packet is used. Why? Because it contains source IP and destination IP. Okay, let's come one by one. Okay, first of all, what is IP? First of all, what is IP? What is IP? IP is internet protocol. Okay, IP is internet protocol. The protocol which is followed by the internet is known as internet protocol. I mean, yeah, internet usually follows IP protocol. Okay. So here we'll speak about what is IP address and how it is different from MAC address. I told you MAC address, IP address. Okay, IP address, MAC address. First point, MAC address was physical address. I told you it is a physical address. Okay, so what is IP address? It is logical address. It is logical address. Why it's physical address? Why it's logical address? Because this is burnt onto NIC. This is burnt onto NIC by the manufacturer, whereas this is not burnt. Any device can have any IP address. How? I'll explain you. I'll explain it sometime. This is okay. Burnt onto NIC by manufacturer. Any device can have any IP. Okay. Third thing, this is on data link layer. This is on network layer of OSI model or TCP/IP model. Okay. Why do we need IP is the question. Why do we need IP? Example. First of all, internet only understands IP addresses, and the routers which are used to forward the data packets, those forwarding of data packets is done on the basis of IP address, not on the basis of MAC address. Not on the basis of MAC address. The forwarding of data packets is done on the basis of IP address, and that is the reason we need IP. Okay, internet doesn't understand MAC addresses. Internet has no idea about MAC addresses. Okay, internet understands only IP addresses. Okay, and you understand about IP address. IP address is a logical address which is used to uniquely identify a device into the network. Okay, what is scope? Uniquely identify a device within a network or scope of network or subnetwork or virtual LANs, anything. Logical MAC address, physical address, this is used to uniquely identify a device across the globe. Unique across the globe. Unique only within the network or across a network. That's it. Unique across the globe. That's the difference. Okay. Architecture of router. Architecture of router. How router works, or what router composes. Components of router. Okay. First of all, each router has an input port. Port or ports. Number one, input ports. Number two, output ports. Okay. Number two, output ports. Number three, routing processor. Number four, switching fabric. These are four components of a router. Now, what all these does? First of all, I would like to draw a diagram. Okay, we have input port here, 1, 2. We have input port here. We have switching fabric here, and we have output port here, and we have a routing processor here, which is connecting both switching fabric and this. Okay, this is input port, this is output port, and here I'm showing only one input port and one output port. Generally, router has many input ports, many output ports. Okay. Now, first of all, what is input ports? Input port is a port through which data packets enter into the router. Data packets or data frames or data through which data enters into the router. That is nothing but input port. Now, input port internally does three works. First of all, how you will remember these three works? How you will remember? Remember it like 1, 2, 3. Three works. One work for physical layer, one work for data link layer, one work for network layer. One work for network layer. I told you router is a network layer device. It operates as the layer 3 of the OSI model. Okay, that is the reason it is taking care of physical layer, data link layer, network layer, all three. Now, first work, physical layer. What I told, physical layer, is responsible for physical connection of devices. Now, input port, the first component of input port is responsible for where the physical connection actually ends at the router. This is where the data comes through some Ethernet cable. Example, this is Ethernet cable. This connection ends here. So here the input port, this component of input port is responsible for the place where the physical connection actually ends. Physical connection actually ends. From here the data enters the router. Okay. Now I told you this second component, I mean the second component of input port, not router. Second component within the input port does data link layer functions. What data link layer usually does? What data link layer usually does? Now here this is a place where router strips off the frames. What is a frame? What is a frame? I thought you, I think you remember. Frame is nothing but destination source MAC, destination MAC, and this is followed by user data. Bro, frame is nothing but combination of user data, source MAC address, destination MAC address. That's it. Okay, for now you can remember this. I'll teach in depth in data link layer, CRC, cyclic redundancy check, and what are those headers like? We have LRC, longitudinal redundancy check. We have all those algorithms, right? I'll teach you later. For now you can think frame as data at the data link layer is known as frame, and the data at the network layer is known as packet. Okay, understanding? So here at the second component of input port strips off the headers and trailers of the frame. Remember, headers of the frame contain the source MAC address and the destination MAC address. Here the source MAC is nothing but source address, I mean the address of the device which has sent the request. Okay, destination MAC is nothing but router's MAC. Destination MAC is router's MAC. Okay, now router will check. Router knows its MAC address. Router will check if the destination MAC belongs to me. If the destination MAC address is my address, only then it will accept the packet. Only then it will remove the headers and trailers. Inside we have an IP packet. Okay, bro. At the application layer, the data is formed. Example, youtube.com. As a request structure to youtube.com, the data is formed. Okay, then it comes to transport layer. It creates a connection, TCP connection. Then this request data goes into a segment. That segment will again go into a packet. This is segment, this is packet. This segment goes into a packet. Now packet has source IP, destination IP. Again this packet goes into a frame. This whole packet, this is packet. In this we have segment. In this we have frame. In frame we have again source MAC, destination MAC, and cyclic redundancy check headers. I mean check headers basically for error-free transmission. Okay, and this frame again goes in the form of bits in the air or in the Ethernet cable. So to access this packet, we must first remove frame, right? We should remove this frame, we should cut off this frame, and then only we can get access to packet, right? I told you router only understands IP address, and IP address are present only in packets, not in frames. Am I right? Yeah. Okay. So now the router strips off these headers and trailers. Now it has got the IP packet. It will check the source IP, it will check the destination IP. Okay. Source IP is nothing but from where the request has come. Destination IP is nothing but youtube.com. Okay, youtube.com. On the basis of that, okay, it will send to next component, which is network layer. Network layer component of input port. Network layer component of input port. Now it takes the destination IP. Okay, now this is actually the one which sends to the routing processor to perform routing. This component is the one which actually sends to the routing processor to perform the routing. okay, which sends to the router, bro, I have destination IP, YouTube IP, please check in your router from which interface the data should go out. Okay. Now input port is over. Second, I am going to teach about switching fabric. Switching fabric. From the diagram only you can see of router. Switching fabric is connecting input port to output port. Simple. Okay. The component of router which is responsible for connecting input ports to output ports and output ports to input ports, vice versa. Ashte. That's it. This is what switching fabric does. Okay. Now there are two ways through which switching is done. Okay. I mean, first of all, what is switching? The ability of the router, I mean the component of the switching fabric, to connect input port to appropriate output port. Okay. I said in this diagram I have drawn only one input port, one output port. But basically routers have, generally the basic router have more than 4 input and output ports. Okay. Now suppose this output port is for modem. Modem is nothing but which provides internet, ISP, through ISP. Suppose we have another output port which is going to another router. Okay. Okay. Now this router, switching fabric is the one which decides on the basis of the IP in the packet, destination IP in the packet. I told you destination IP is youtube.com, right? Now switching fabric will say, okay, the destination IP is youtube.com. I should connect that packet to this output port. Why? Because it should go to internet, not to another router which has another LAN. Because YouTube server is not present in this line. YouTube server is present in ISP, internet service provider. I mean, it's not present in ISP, but the ISP is the one which will help it to reach the YouTube server, which is sitting in USA. Okay. So this thing decides to connect correct input port to correct output port. Okay. Now that is done by means of two ways. Switching via memory. Switching via memory is very simple. So basically here the switching fabric works as traditional CPU. Here the CPU is programmed in such a way that it knows to connect which input port to which output port on the basis of some software. Through some software it is programmed. Okay. So how today's generation CPU works? It knows when to connect CPU to monitor, when to receive values from monitor, when to receive values from keyboard. I mean, when to send to monitor, when to receive from keyboard, when to receive from mouse and all, when to send it to printer. How the CPU is programmed. In the same way, this switching fabric, switching via memory is also programmed in the same way on basis of some software. When should one input port connect to that output port? When should another input port connect to that output port? Okay. It behaves in such a way. And we have one more thing, switching via bus. I told you in bus topology we have a single cable running in which multiple devices are connected. Single cable. Okay. This is also actually same. Switching fabric is like a bus here. We have multiple these ports can be thought of devices. We have multiple ports. Here we have multiple output ports, multiple input ports. These are like devices. Okay. Now in bus topology what used to happen? A device used to send the data. Okay. Now this data goes to all other devices. Okay. Now only the device with destination MAC address same as its which is present in the frame. Bro, A device is trying to send data to C device. A in its data has source MAC, has destination MAC, has user data. Okay. Now the destination MAC is C's MAC address. When the data goes to all devices, they will check if the destination MAC is mine. B will say no, it's not mine. D will say it is not mine. E will say it is not mine. But C will say yes, this data is mine. Then the C will accept this data. Remaining all devices will reject this data. Okay. Okay. In this way only, here also switching via bus happens such that all input ports are connected to all output ports. Once an input port sends out the data, all output ports will receive it, but only the appropriate output port will accept the data. Rest all output ports will reject the data. That's it. What basically happens? Input ports puts a token. Suppose this output port accepts token 2, this output port accepts token 1. So this input port puts token 1. Now it will go to this, it will go to this. This will say, okay, this is token, it contains token 1, it is meant for me. It will remove the token, it will send out the data to the interface to ISP. Understood? Okay, this is nothing but switching fabric. Third component, routing processor. Simple, bro, simple. Routing processor, also known as traditional CPU, is actually the place where the routing information protocols are running. Hey man, not routing information protocols. Actually, where the routing protocols are running. Routing information protocols is a particular protocol. Suppose this router is using distance vector algorithm. Routing processor will use a distance vector algorithm. On basis of that, it will decide which output port to connect. Okay. So this is the place where actually the forwarding table is getting used. Forwarding table is actually placed in the routing processor. Okay. Fourth, output port. Output port or output ports, anything you can say. Now you see here also I have drawn 3 boxes. Bro, here you see this box, right? The first component of output port, or the first first component of output port is responsible for maintaining the queues. What are queues? First in, first out. FIFO, first in, first out. Those are queues. This component is responsible for maintaining queues. Suppose there are 2 input ports which are trying to send the data to one output port, then this output port has to decide which data should I pick up first, or how should I send it in a faster manner. If two data, I mean the 2 formats of data come at the same time to it, okay, it maintains a queue such that this data, okay, queued here, second data queued here, now this will go out first, this will go out next, on some basic principle, first in, first out. Okay, these are nothing but queues, basically maintained so that it should adjust. It's not just like send, no. Properly take it, properly remove it. Okay, no data should be lost during transmission. Okay, this component is responsible for queuing. Okay, maintaining queues and buffers for incoming data. That's it, simple. And again, same as this thing. This is data link layer function, this is physical layer function. So data link layer function, so this is nothing but, I told you here it removed the frame headers and trailers. Okay, at this layer at the output port, it will again add headers and trailers to the frame. Now the destination MAC will be either modem's MAC or another router's MAC, depends, or directly device, depends. It will add the headers and trailers to the frame. Okay. Now third thing, physical layer, nothing but this component of output port is actually responsible for creating a physical connection again to another device or another router or another modem. That's it. Physical connection again starts from here. Here physical connection ends, here physical connection starts. Here frames are removed, here frames are added. Here actually the on the basis of packet IP, I mean the destination IP, routing infrastructure protocol has been decided. Here it maintains queues or buffers. That's it. Routing architecture over. Finish.